Helpful if we just go through the Paymail specification and just kind of discuss what's in it. I think this might help people understand basically the ideas behind how it actually works technically, which we haven't done, at least not in the form of like a video or something like this when we publish the spec. But before I do that, let me sort of briefly give the background of what is Paymail and like how we created this. So Paymail was a result of several different people involved in trying to solve very similar problems, getting together at the in-chain wallet workshop I think it was in February of this year when we got together and for the first wallet workshop. So the companies involved there were quite a number of companies involved, but if I remember correctly, the wallets that actually participated in this particular protocol were ourselves, MoneyButton, Handcash, Centbee, and Electrum SV, as well as a lot of input from in-chain. In fact, I would say critical input from in-chain on all this stuff. There were other people present too, but I think that those are the companies that, to my memory, sort of really contributed to creating this thing. So all wallet companies. And the big picture vision was something like this. So, because I've been involved in Bitcoin for a very long time, and have been, so I'll give this obviously from my sort of perspective on this, but basically I've been involved in Bitcoin for a very long time and have been trying to figure out how to solve a bunch of problems in Bitcoin generally, but a lot of problems come down to what I call the identity problem, which is basically how to use cryptography somehow to represent people's identities on Bitcoin. Because you basically need some way of knowing people to be able to then do things. Like, for instance, you need to have like a legal name to be able to sign stuff. So you need the identity in order to be able to create a legal contract. They're attached. And then you need that identity to do all sorts of other things, like sharing a document, posting to social media, sending and receiving messages, having a contact list, having a friends list, having a following list, following people, things like this. So anything that you want to do seems to revolve around this notion of identity. So we need some solution to this that works. And a key part of the identity problem is having a naming system that actually works. And let me then back up and say that there's a role model in the industry called Handcash. So Handcash had a proprietary solution to naming that worked extremely well for their application. And basically the way this worked is in the Handcash wallet, everyone has a handle, which is it starts with a $ and then it's a name. And the idea is that each person gets a name and then you can pay to other names. And so this is much more user-friendly than Bitcoin addresses. It's a very friendly system. The only problem is their solution was completely proprietary. And although it works very well for them, it's a big ask to have every other company in the industry use Handcash's proprietary system. So it would be preferable if there was something like Handcash, but that was a generic protocol. And so we'd want to do something like the way that Handcash worked technically, which is whereby you can query a Handcash handle using an HTTPS endpoint and get an address that you can then send money to, so that the user never sees the address, but the address actually still exists under the hood. And so meanwhile, I was thinking about all this stuff. I was influenced by Handcash, and I've been thinking about internet technologies and things like this whole time. And so I had this idea to use email addresses because email addresses are something that, well, first of all, we're already familiar with them. And secondly, it sort of has all the right technical properties. It works very similar to Handcash, but it wouldn't be locked into one particular company. It would be something where any wallet company or something like this, or any company of any sort, could have something like this, and then they would have like their own namespace. So email addresses seemed like a natural extension to this, and then we could leverage standard internet technologies to do the sort of the same thing, where you could use a DNS endpoint to basically specify where the HTTPS endpoint is located, and then start putting services there, particularly a receiving address for the what would become known as Paymail later on, a receiving address for the email address to send money to it. So I had sort of come up with my own solution to this, and at the wallet workshop, the funny story is that I, at some point when the time was right, I spent maybe 15 minutes or so working through with other people there what the solution would look like, and explaining my expansive sort of, you could call it a sort of extension of Handcash to the form of a protocol that anyone could use. Finally I get to the end of this thing, and there's somebody sitting on the side whose name is Andy, who says, "Hey Ryan, that sounds like a really good idea. Would you like to see a fully working implementation of everything you just said?" And so he pulled all of us over to another room and showed us a working demo of everything I said. So it was really funny because, of course, him and I basically independently thought of just about, I would say it was about 80% equivalent solution to this problem. Now, for me, I had only had the idea. I didn't actually implement it. He had actually implemented it. So what then followed was it became pretty clear that we're onto something with this idea, and everyone was pretty agreeable to using something like this. And so I guess you could say we sort of proceeded to figure out how to turn this into a spec and software and stuff like this. So let me show you the spec. So the spec was mostly written by Andy. I am a co-author of most of the documents because a lot of my ideas are pretty much the same as Andy. I don't see where the co-authors are. Oh, I think they're over here somewhere. Let's see here. Many of them you'll see, like this one right here, it's Andy and myself. But in fairness to Andy, Andy wrote almost all this stuff. And his idea was actually slightly better than mine. He had a bit of a more sophisticated view. He had this idea of a .well-known file that's being used in here, which I'll explain when I go through the spec. So we should really give a bit more credit to Andy for really actually writing it and creating an implementation of everything. And I just get to be listed as a co-author because I had the same idea, and Andy's nice and listed me as a co-author. But it is true that we independently invented the idea. Okay, so what I want to do is let's just go through here. So first of all, we're at bsvalias.org, and I kind of somewhat deliberately am on the not secure version. Let's go to the secure version, which is https://. And this is a sly sort of hint to in-chain to what you should do is redirect the HTTP version to the HTTPS version. But yes, I know it's irritating to set that up. But in any case, it's bsvalias.org, and you can see all the specs here. And it's at BSV alias because the story behind the name is that this is just what Andy originally called it. But we started brainstorming names, and I believe it was Alex Appiget who came up with the name Paymail. And that seemed like the perfect name. It seemed to perfectly capture what it is that we were doing. And so everyone just sort of easily agreed that, well, yeah, I mean, obviously it should be called Paymail. But in any case, the spec is hosted at bsvalias.org. But the BSV alias, sort of spec is Paymail. That's just what it was called before we had the cool name Paymail. Okay, so inside the spec here, we've got a few different things. So first of all, Andy has this wonderful notion of a BRFC specification. And the idea behind this is actually we need a way to create extensions to Paymail whereby it's permissionless and sort of decentralized in the sense that you don't have to go through some organization to create new specifications. So the idea is you can write like the title of whatever your extension is, and then the name and the version, and then hash it and get an identifier. And so these identifiers are actually used inside the Paymail spec because we use these things to identify extensions so that we never have like basically it allows anybody to create an extension permissionlessly. That's the idea, without conflicting with anyone else. So I don't want to go through and explain what it is exactly, but you get the idea. It's the name of the spec, the person that created it, and the version number, and then the hash of that, and it's like the first few bytes of the hash. And then the interesting part is simply that we deliberately leave out the document itself from the hash, so that way you can update the document without changing the hash. So it's just a nice way to allow anyone to create new extensions to Paymail without ever worrying about conflicting with anybody else's extension. Okay, so the first thing we should go through here is service discovery. So the idea behind this is something like, okay, so if basically given a Paymail, which looks like an email address, we need a way to figure out, like what we can do, because the whole point with Paymail isn't to solve everything in a single protocol. It's to create an extensible protocol that allows us to create new, sort of services, or perhaps we should say capabilities, as it's described in the spec here. Okay, so first of all, we have host discovery. So the idea behind this is, so if a Paymail is a local part in a domain, local part at domain.com or whatever, .something, what we want to do is we need to know where to look up the HTTPS sort of endpoint to get more, to know what the capabilities are. So the first sort of innovation of Paymail, so to speak, is to use this idea of SRV records, which is a way of specifying a service for a domain name. And so we specify the BSV alias service, which then gives us another domain name, which can be the same domain name or it can be a different domain name, which contains a .well-known file. Now, the purpose of doing it this way is to make it really, really, really easy to do third-party hosted Paymail services. So that if you have yourbusiness.com and you want to use, say moneybutton.com as your wallet, it should be possible to basically redirect your domain name to MoneyButton. Now, that doesn't redirect your website. What it does is it redirects the Paymail hosting only to the third-party service, which in this case would be MoneyButton. So what you would basically put in here is you would put moneybutton.com in the target, and that's a way of specifying that the domain name that actually hosts Paymail can be a completely different domain name than what your domain name is. So if you own your own domain name, but you don't know anything about creating Bitcoin wallets, you can actually still use your own domain name for Paymail. You just need to find a third-party host. And it does so happen that currently we do have support for this in MoneyButton, and we host this for a few other people inside MoneyButton. So there are some people that actually have their own domain name hosted on MoneyButton. We haven't exposed this publicly yet, but you can get in touch with us and we can set it up for you if you want to do something like that. So we actually can host your custom domain name on MoneyButton. Okay, so that's the idea there. Now we need to move on to the capability discovery. So this was one of Andy's innovations. I didn't quite think this detailed. And so Andy had this wonderful idea of using the .well-known. I forget what this is called, but the .well-known directory is like a standard way to put sort of extensions inside of websites. And so he created this BSV alias .well-known file. And so after, and the user never needs to know any of this stuff. I mean, obviously this is a spec, and so I'm describing to you everything that the developer needs to know. But in any case, or the wallet needs to know. So the wallet sort of queries the domain name it hosts it, and then looks up the .well-known file for the domain name. So for instance, let's suppose you have your name at yourbusiness.com that's actually third-party hosted by MoneyButton. If you send something to your name at yourbusiness.com, first it looks at the SRV record, finds out that it's actually hosted by moneybutton.com, then goes to moneybutton.com and looks up the .well-known file. And the .well-known file is what contains a list of capabilities. And so the capabilities, and we'll explain a couple of them, but I'll explain the vision for how we can add more capabilities, are listed inside of the .well-known file. So basically, when you extend Paymail, the idea is to go edit that .well-known file and then add new capabilities here. Now, for these basic ones, there's not a hash here, but the idea is typically to use a hash, like this one right here. So this is an example of one that would be like you create an extension, and you put that little hash that I was saying earlier, the BRFC hash. You put that there, and then that way you can have, like, people can create as many capabilities as they want to that never conflict with one another because they all have this random-looking hash as the identifier. So anyway, what I'll then explain is basically what are these PKI and payment destination things. But anyway, I guess that's pretty much it. I mean, there's a bit of information here about how to actually query it, but the whole idea is basically it's literally just a file that tells you what the capabilities are and then basically gives you a new endpoint for how to query those capabilities. So I hope this is clear so far. If it's not already clear, it'll probably become clear when I explain what some of the basic capabilities are. Okay, so let's move on to the next one. So in the previous video, this is what I was referring to as the identity key. So Andy has this listed as the public key infrastructure, and I called it the identity key. And basically the idea of this is attached to each Paymail is a public key. And so the way this works is in the .well-known file, you have the PKI endpoint that basically tells you how to query the public key of a Paymail. And so that's all it is. It's literally just a public key. Again, there's additional information here. It's a thoughtfully written spec, but the basic idea is you put a Bitcoin public key there, and that's it. That's the entire sort of spec here for the public key infrastructure, what I call the identity key. But if you understand the vision, you realize how incredibly powerful it is to have this availability there. So literally, that's all it is. Basically, is an endpoint to query a public key. Actually, there are a couple of other things here I'm trying to see in the spec. I don't want to try and read it in like extensive detail here, but you do need also the ability to do things like confirm whether a public key belongs to a Paymail. And I'm not really seeing that. Let's see here. Let me see if I understand it quickly enough. I don't want to try and read the entire thing in detail and read the spec. But in any case, you need a couple of features, which is the ability to actually get the public key, as well as the ability to check whether a public key belongs to a Paymail. Okay. So given all that stuff, that might be in a different place. Oh, here, we have a different protocol for that. That's the answer to that. So it's in a different place. Okay, in any case. All right, so let's move on to the next one. So the public key infrastructure is used for signing and encryption, if that's not clear. It's actually not used to receive payments, all right? So the payment addressing, well, these are the specs built in related to actually sending money, okay, which is, a little bit more what you'd expect. But we had to build in the PKI just because, well, gosh, it brings tremendous power to this to basically be able to have signatures and encryption built in to Paymail. And it's really quite simple, too, if you think about it. Like, all we have to do is expose this public key. All of a sudden, you can start doing things where people can look up your public key and verify signatures and stuff like that against your Paymail. It's incredible, okay? But that's actually very different than sending money. So for sending money, what we really want to do is the ability to retrieve an address. So that's what this one here is for, payment destination. So again, we list inside the .well-known file, there's a URL that tells us what how to query an address. And an address is where to send money. That's basically it. And I don't really want to go through all this. Okay, so there's a bit of extra information here about things like how to do things like verify the sender and stuff like that. I think that's in here. So I guess it's a different section here. There is a place to put a signature for that stuff. I don't want to go through it in detail. We'll probably be, let's just say, I just don't want to go through it in detail. But the basic idea of this one is the ability to query an address, okay? All right, so the next one, sender validation. This is another one. I just want to go through this in detail, but the basic idea here is we have thoughtfully included the ability to actually like verify who is sending you money. So it's like who is actually querying the address. So we have the ability to like sign something that says, here's the Paymail of the person that's actually requesting your address, so that you can know who the sender is. So it's also a thoughtful thing. I believe this was Andy's invention. Yeah, actually, Andy didn't even list me as a co-author of this one, so it's clearly Andy's invention. But anyway, it's a very thoughtful idea. We sort of have support for this in MoneyButton. We no longer enforce it because it makes it so much harder to implement Paymail that we decided not to enforce it. But in any case, it's just a way to basically specify who is actually sending you money, okay? Receiver approvals, I don't remember what this one is. Let me just read it. Receiver approval is extension of both basic sender values, use a callback based flow, blah, blah, blah. Additional steps receiver introduces. This sounds very related to, maybe this is something where like you can specify who can send you money or something. To be honest, I'm not sure, and I'm not going to try and interpret it on the fly as I read through this, but this is probably related to the sender validation stuff. But presumably it has some ability for people to deny it or something like that. But to be honest, I'm not sure. It's a bit embarrassing as I go about reading this, but I don't know. I actually don't know whether we're actually using this one or not. There's one final piece. So this is just a way to specify basically a URL to go to a Paymail and how to specify an amount and a purpose. So this is like if you're familiar with things like how to click like a link on a website and open up a link. The idea would be we need a link that makes sense for Paymail to basically pay to a Paymail. Okay, so I hope that's clear. And then the final one is what I was trying to describe earlier. Looks like Mige is one of the co-authors of this one. So Mige wrote all of the MoneyButton infrastructure for this. And he helped create some of these things. So create some of the specs, including this one. So the idea behind this is that in order to, when you want to validate a signature from a Paymail, you want to check that the Paymail owns the public key, but you don't want to simply look up the public key for that Paymail because the public key may have changed. So you actually need something different. You need a way to check if a public key corresponds to a Paymail rather than to actually get the public key. So I hope that's clear. Okay, so I think that's it. That's all I want to talk about in this video. I'm going to describe a couple things. I hope this is all What I'm saying is clear. We'll create, as I said in the previous videos, we're going to create more information about all this stuff and graphics and everything. But I just thought it might be helpful to go through and verbally explain things as I see it in the specification. So what you don't currently see in the specification are things like a BIP 270 and a peer-to-peer transaction broadcast endpoint. As I've described elsewhere, what we're currently working on is a peer-to-peer transaction broadcast endpoint in collaboration with other wallets who I won't be naming just because I don't want to call them out or something like this. But we are working with other wallets to create the peer-to-peer transaction broadcast endpoint and move to a peer-to-peer model for payments in Bitcoin, where you actually deliver the transaction to the recipient. And so this will take the form of a Paymail extension. We're probably, I would say, 99% likely to do something simpler than BIP 270 for people that are familiar with BIP 270. I don't want to explain that right now, but I'll say that what we are doing is strictly simpler than BIP 270. We're implementing the peer-to-peer transaction broadcast endpoint of BIP 270 first, to be followed by more sophisticated features later. So the reason why this matters is, so if you look at like the spec here, I mean, so you have the ability to get an address, but it's like, okay, so let's suppose I create a transaction to someone. Where do I send it? Well, the way everyone sends it right now is to give it to the miners, but we don't want to give it to the miners. We want to give it to the recipient. So there's a missing piece here. There needs to be like one more, section 4.5 or something like that says, where do I actually give the transaction? You should be able to post the transaction to an endpoint where they can receive it directly, and then the sender doesn't necessarily send it to miners. The recipient should be the one sending it to miners. So you can watch the video I created about SPV and where I talk about some of those things. There are a lot of reasons for this, but basically this is going to scale. It makes it so that the recipient does not have to scan the blockchain to receive their money. They just receive the money directly. It's how you send transactions peer-to-peer in Bitcoin that no one's currently doing, and so that's why we have to create all these protocols and infrastructure so that we can start actually delivering transactions peer-to-peer. That is not currently in the spec, but that's what we're working on next. So when we launch that, I'll be able to create a video and explain how we're extending Paymail, and I'll be able to show you what that extension actually is. It's all written up, everything like this, but we just haven't launched it live yet, and so we'll launch it first, make sure it works and everything between wallets, and then we'll announce it and show the spec and everything like this. And that's why I say, like, if you are interested in being involved, please just get in touch with me directly, and I can clue you into all the information. We can test with your wallet and stuff like that if you're interested in doing something like that. Okay, so that's all for this video. I hope this was helpful to some people, people that are implementing Paymail or people that are just interested or whatever. And I really appreciate all the feedback. And if you have any more feedback for things I can do with these videos, I realize probably the most valuable thing I can do is create illustrations. I plan to do that, but that takes more time and effort than just talking into my camera here. So I'm doing it this way first because I can get this useful content out there for the people that are in the industry. And over time, we're going to improve the quality of this stuff to create more illustrations and expand the scope of the audience that can actually consume this information with illustrations and animations and things like that too. All right, so that's all I have to say for this video. So thank you very much for watching.